All right, guys, like I said, I would give you another example of a proof that you can use when trying to prove two triangles are congruent. But in this one, we're going to go a little bit further than just proving two triangles are congruent. We're going to use the acronym CPCTC. So if you remember, corresponding parts of congruent triangles are congruent. So we're going to use that aspect and extend the proof past just two triangles being congruent. So what we're going to look at here is in this particular problem, we have our diagram that's drawn out and we have our given information. And our goal here is to prove that segment ML is congruent to segment MN. So those are parts of the two different triangles that are created there. So let's start with our first statement and reason. Our first statement, we see that those two particular angles are congruent. Why are they congruent? If you look above, it says that it is given. So since it's given, we can state that it's congruent. Okay, what can we do next? Well, we can go ahead and say that MO, segment MO, is congruent to, what do you think? MO, right? Perfect. It's going to be congruent to itself. So if it's going to be congruent to itself, what's the reason for that? Again, those properties of congruence, it's going to be that reflexive property. Okay. Now, if you look at the diagram, it's being marked up each time that we go ahead and make a statement. So this way, it starts to help us to see visually along the lines of, okay, well, which of those triangle congruencies can I start to think about using as I'm marking my diagram? Right now, you might be able to use angle, maybe angle, side angle, side angle, side. Who knows? Maybe it could also still be angle, angle, side. We definitely know it's not going to be side, 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 right? Because so far we have just one pair of angles and one pair of sides that are going to be congruent if we had two separate triangles there. All right, let's continue on. So we've already used the reflexive property. Now, what can we say about angle LMO? LMO. Well, we can actually say that angle LMO is going to be congruent to NMO. Why is that? Well, if we go back to the information at the top, we notice that it said that OM bisects angle LMN. So what does that mean? Do you remember what it means to bisect? It meant to cut something into two equal parts. So in this case, we're going to have two angles that are congruent. So it's the definition of an angle bisector. And that's part of the notes you should have already taken. So now we can say that the two triangles are congruent. LMO and MO are congruent to each other, these triangles. So now, what is the shortcut? If you look, what is marked up? Well, we have an angle, we have a side and an angle. See the sides in between, so it's the angle, side, angle. Now we have two congruent triangles. And finally, our last thing that we have to do is we need to go ahead and say our last statement, which is that segment ML is congruent to segment MN. Why is that? Remember, going back, the whole idea of this is to try and show that the corresponding parts of congruent triangles are congruent. Well, that's exactly what you would say. You know the two triangles are congruent, so that means all of the corresponding parts are going to be congruent to each other. Because if two triangles are congruent, all six parts of one triangle are congruent to all six parts of another. You just find the corresponding parts that are congruent and you're done. So here's the proof that you have for showing that those two line segments happen to be congruent to each other. I hope this helps clarify a little bit more in using that application of CPCTC.